Hello trainees. Welcome to today's class. Today, we are going to discuss about two topics. The first one is tolerance. Let's see the objective of this topic. You shall be able to state the method to express tolerance. Now see the definition for tolerance. Tolerance is the permissible limit, or limits of variation in a physical dimension, a measured value, or physical property of a material. And next, we are going to see about methods of expressing tolerance. The first point is, note whether it is an internal measurement or an external measurement. And the second point is, note the basic size. And the third point is, note the combination of the fundamental deviation and the grade of tolerance. And the last point is, refer to the chart and note the upper and lower deviations, which are given in microns, with the sign. Accordingly add or subtract from the basic size and determine the limits of size of the components. Now, we can see one example for this. First, it is an internal measurement, so we must refer to the chart for holes. Second, the basic size is 30 mm, so see the range 30 to 40. And the third step, look for ES and EI values in microns for H7, combination for 30 mm, basic size. It is given as. Therefore, the maximum limit of the hole is 30 plus 0.025 is equal to 30.025 mm. The minimum limit of the hole is 30 plus 0.000 is equal to 30.000 millimeters. After the completion of tolerance topic, we are going to play one quiz related to this topic. The question is: what is the maximum limit of the hole 30 H7? The options are 1. 30.0025 2. 30.25 3. 30.025 and 4. 30.035. The answer is yes, you are right. After the completion of tolerance topic, the second topic is vernier height gauge. Let's see the objective of this topic. You shall be able to identify and name the parts of a vernier height gauge. State the constructional features of a vernier height gauge. State the functional features of a vernier height gauge. Identify the various applications of the vernier height gauge in engineering. Now, see the definition of vernier height gauge. Vernier height gauge is a special type of vernier instruments, which is used to measure heights of different engineering objects, up to high precision and accuracy. Let's see the parts of vernier height gauge. The parts are beam, base, main slide, jaw, jaw clamp, vernier scale, main scale, finer adjusting slide, finer adjusting nut, locking screws, and scriber blade. Now see the construction of vernier height gauge. The construction of a vernier height gauge is similar to that of the vernier caliper, that it is vertical with a rigid base. It is graduated on the same vernier principle which is applied to the vernier caliper. The beam is graduated with the main scale in mm, as well as in inches. The main slide carries a jaw upon which various attachments may be clamped. The jaw is an integral part of the main slide. The vernier scale is attached to the main slide, which has been graduated to read metric dimensions, as well as the inch dimensions. The main slide is attached with the finer adjusting slide. The thickness of the jaw is marked on the instrument, as like in a vernier caliper. The least count of this instrument is also 0.02 millimeters. An offset scriber is also used on the movable jaw when it is required to take measurement from the lower planes. Next, we are going to see about functional features of vernier height gauge. Vernier height gauges are used in conjunction with the surface plate. In order to move the main slide, both the locking screws of the slide and the finer adjusting slide have to be loosened. The main slide, along with the chisel pointed scriber, has to be set by hand for an approximate height as required. Some vernier height gauges are equipped with a sliding main scale, which may be set immediately for the initial reading. This minimizes the possible errors in reading the various sizes in the same setting. Another kind of modern vernier height gauge has a rack and pinion set up for operating the sliding unit. Let's see the uses of vernier height gauge. The vernier height gauge is mainly used for layout work. It is used for measuring the width of the slot and external dimension. The vernier height gauge is used with the dial indicator to check hole location, pitch dimensions, concentricity, and eccentricity. It is also used for measuring depth with the depth attachment. It is used to measure sizes from the lower plane with the help of an offset scriber. And last, we are going to see about care and maintenance of vernier height gauge. After using the vernier height gauge, you should wipe the measuring faces with a clean, dry cloth. After use, it is important that you should check the beam of your vernier height gauge for any unwanted residue that may affect the sliding motion of the vernier scale. Apply a small drop of oil to the beam of the height gauge. Clean it with a cloth and slide the vernier scale backward and forward a couple of times. Vernier height gauge should be stored in a well-ventilated, humid-free environment. Most height gauge come with a protective case to keep them safe when not in use. You should regularly check the calibration of your height gauge to make sure that it is working correctly. After the completion of vernier height gauge topic, we are going to play one quiz related to this topic. The question is: what is the part marked as X? The options are 1. Beam, 2. Jaw, 3. Base, 4. Jaw clamp. The answer is yes, you are right. With this, we are completed both the topics of tolerance and vernier height gauge. I hope all are get some information about tolerance and vernier height gauge. I will be back with the new interesting topic. Thank you.